the sort of main purpose of today is like it's going to be mostly just a live coding session type thing. But I also just wanted to, uh, yeah, like the purpose is to sort of explain how Roact works and how to use it. We probably won't go like super in depth on anything, and we might have to do a future session if you're interested in seeing more. But yeah, I'm gonna explain a bit of how Roact works, just enough to be useful, and we're going to use that to get a little further in creating the tool menu for selecting different pens and erasers and adjusting the sizes and colors when you're using Metaboard in VR. Um, so uh, so this is mainly about React. I don't really have a lot of prepared points, but the main point is that it's declarative. You might have heard this distinction between declarative and imperative style programming. And the distinction is that whereas with imperative programming, you sort of exhibit a sequence um, of steps through which your code will execute each of those things. And so if you're creating something like a UI, you like in order you create whatever instances you like, and if there's any interaction with them, you sort of set them up in some sequence. And if any changes happen to that UI, you sort of manually destroy things and create things. Like that's sort of all up to you in the imperative style. Declarative is essentially like doing things in a declarative way usually means there's some layer of abstraction that's taking care of that, like creating and destroying things. And uh, the purpose is to just declare what instances should exist, and the sort of layer under the layer of abstraction is the one that takes care of creating and destroying things. So so how does so what does that actually mean? Okay, so when you create a UI, some kind of user interface with React, um, the strength is that you have some top level state which sort of describes what your UI should look like at that moment in time, and so you sort of visualize that at the as the sort of top level component. Um, so in your top level component, you have some state that describes your UI just in with like data, just Lua data. Um, that's at the top of your program, and usually with creating a UI, some kind of menu, you have some sort of background. Just here's an example. We just have some background with some buttons A, B, C, D. And there might be different menus and pages, but uh, this sort of exhibits kind of a hierarchy of components where, like, you have maybe if this is like one piece of it, and inside there's these buttons, um, you sort of represent that as a sort of a tree of components that represents that that hierarchy. So um, so if I let me just do some example nodes. These are our sort of uh, our intermediate components, and they sort of take care of the UI, but for just they take care of like some subsection of the UI, and basically what happens is uh, say say this is the component for this button here, A. You might have some sort of um, in some situations you might want the button to appear as selected or not selected, and so that might affect like the color of that button. And so what you do is you sort of represent that sort of selectedness state somewhere in your top level component, and you feed that down to the component that represents this button through a table of props. And so you might
Props
have
literally stands for propositions?
no properties.
Properties. Okay. Proposition
Yeah.
could be
So
it's on or off, I guess. Okay, property, yeah.
yeah. So it's sort of the same, essentially the same concept as like Roblox instances have properties, and some of these components. This will probably actually have a special component inside it called a host component, and that actually represents like the frame or whatever it is that is the instance that Roact will create. And so these properties will flow down here, and like up here the property is something like selected, like a selected equals true or something, and that's a Boolean value. But within the logic of your components, that will eventually get transformed into something like at the bottom host component, it'll say color equals red or something. And so, yeah, there's, yeah. So properties flow from some underlying state that represents like everything you need to know in order to like make the host components appear the way you want to. And in the definition of these components, though, there's a sort of function which allows you to say how to take those properties that are flowing from the state and transform them into like instance properties for your host components. So that's a sort of very high level abstract overview, and I hope it'll probably make a lot more sense when we actually start doing some coding. But I just wanted to get across this picture of having like your state at the top and that state flowing down through the props that gets passed to each component.
Thanks.
Okay, cool. So let's actually exit this and move over to. I'll turn on my headset and we'll move over to Roblox Studio. Just give me a moment. Actually, I'll just share my whole screen. Exit this. Okay. Just clean this up a bit. Okay, so firstly, I want to show you this tool called hoarcekat, which I guess one of the sort of weaknesses of doing things with Roact or just like creating UI programmatically um, is that you don't sort of get the live editing that you would in Roblox Studio, where you can sort of click and move things around and sort of update them in Roblox Studio. But there is a very useful plugin called hoarcekat, and I'll just demonstrate what it does very quickly. So what you do, and it doesn't require, it's not Roact specific in any way. So what I'm going to do is create a pretty simple example. What you do is you create a module script, and for the extension to recognize it, just call it test. You end the file name of the module script in .story, and what you return is a function which it gives you a target which you can sort of attach your UI to.
Sorry,
But
but I
when
can't. You're not sharing anymore. Are you intending
oh,
to
I
share?
thought I changed to the screen. Okay, how about now? Okay. Um, okay, so what I did here is I created a module script called test.story there. Is this big enough? Is this viewable?
Yeah, I think so.
Okay, cool. So here's uh, I'm taking in I'm returning a function that takes in a target, and the content of this, it has to be uh, within this function. You sort of set something up, uh, like you attach whatever UI you have to this target or to just somewhere else in the workspace if you're not doing UI, and then you return a within this function you return a function which destroys like a sort of yeah destroys whatever you created. And what hoarcekat does is it allows you to live edit this code, and the thing that you're creating will be sort of automatically updated as you write the code. So, as an example, what we can do is uh, we can just make an instance. So cool. We might have to put this in a particular C frame, but I'm just going to parent it to the workspace for now. And our teardown function would be to destroy it. Okay, so you can see that the extension has recognized my story module script. Yeah, you can see it when I sort of select it. It creates that part at at the location I put it. But what we can actually do is so if we change the C frame and let's just raise it up a little. Uh, can we see this at the same time as? Yeah. Yeah, when it saves, it automatically updates. So I can do it again. Oh, because it's actually auto saving instantly. Um, so for example, we could change the color as well. So this is very useful. So like we can design our UI with Roact and we can just instantly see the changes. It's not as good as like you can't like click and drag to sort of resize things as you would, but you can at least see your changes.
How did you connect hoarcekat to this script, module script?
So it's just it recognizes anything called something dot story.
And it's in that plugin window down the bottom that's like active because it's blue, or it's just.
Yeah,
Yeah, I see.
yeah. I can deselect it and it disappears. Okay, so what you can do in here in particular is you can mount your Roact components to this target or to whatever you want in the workspace, and that's exactly what we're going to do. Um, so let's get started. Yeah. Try and resize this to a nice portion. So it's going to be easier if I do it uh, within the metaboard code base. So what we're going to do is create a, a module which will be our sort of top level app, our top level component. So I'm going to call that tool app.lua and just import some stuff that we'll need. So I've just imported the just the common files that we need in metaboard, which in particular houses the Roact package. And with this, we can create our top-level component, which is I'm just going to call it tool app, right? So component. So, you got to write extend. I don't think the name here matters. It might just be a debug thing. And so the main method that tool app is going to implement, which sort of explains what this component is supposed to look like, is the render method. And in particular, there is so because this is an object with self.props. This is where if someone was when this component gets created, it gets passed in a bunch of props, and they're available through self.props. But the job of render is we're supposed to return something to view. We need to return what an element. All right, I didn't explain what an element is. So you can look at the Roact documentation while we're doing this if you're interested. But there's this subtle distinction between elements and components. So components are sort of higher order in that you can't mount a component because you need to give it props first. So what an element is just a component but with the props provided. So this is an example of providing this size property to the host component called frame. And you can also do a similar thing with different kinds of components. I'll continue for now. So, and a typical thing is to use this keyword. I'll just use the letter E for instead of typing roact.create element. So we're going to create. Let's just create a part like we were doing before. And let's frame it to the middle of the workspace. Let's give it a color. Okay. So right now we just have a component, but we need to connect this to hoarcekat. Sorry, just give me one moment. Sorry, I'm back. Okay. So we have this component, and we just need to make a story file that will actually mount it. So I'm going to call it tool app.story. Oh, .lua. One sec. I just need this again. So once again, I'm returning a function which it's just going to mount it to the workspace. So this is the function for mounting. Let's make the element first. So we need our component first. And at the moment, our tool app doesn't actually use any components. I guess let's make it take the color as a um, as one of the props. And so here we can specify that. And then we'll mount it. The mounting function gives you a sort of reference to the resulting tree of Roact elements, which you can then use to unmount it. So we're going to parent the result of this to the workspace. And let's just call it cool app. So that mounts it, and now we need to give hoarcekat back a function which it can use to unmount it. Okay, so this should work. Oh, I need to sync it in. Okay, cool. So here's tool app. Okay, I broke something. One thing with Roact is that the error messages are sometimes helpful, but usually not great. Okay. Okay, this is just a little hiccup with the way we have the metaboard package structured. I won't really explain it in depth, but while I'm using hoarcekat, I'm going to need to copy this common file over to replicated storage, and that will help this work. And I have another error. Known element kind nil. Oh, I remember why. Because I have not returned the component. So that should fix this. Okay, cool. And so you can see if I change the color here and save it, as soon as I save it, I get a new, I get my tool app has updated with that new data. Okay. So let's make something interesting with this. What we want to do is we want to pick up where we started last time, which was we want like a sort of palette like to appear on the left hand uh, of your character. And so I've actually got a character here that we can use to like so that I don't have to go in and out of like the VR testing by playing the world. We can just use this this model. Okay, so how are we going to do that? So what we should do is okay. Here's our first interesting component. Sorry, our first interesting property is going to be we're going to request the character, and uh, and then in this part, um, we're going to mount it at a C frame according to that character. And let me just get the properties that I prepared earlier. Okay, so let's get a sort of frame of reference, which is going to be origin, which is character left hand. Just get the C frame of that, and I'm just using the C frame math we figured out last time. Minus math of pi. Actually, I'll show you like refiguring out this part. Let's just put it right there. Let's put it at the origin. Right now it's giving me errors because we haven't actually passed this prop in. So let's let me grab the character. So when I'm sort of in testing mode, I don't actually have. It's different to when you run the game and we need to get the actual character of the local player. And so this is the strength of using props, is that we're kind of signaling that this component can be used in like different contexts, and it's not my responsibility to figure out what the character is. I'm going to receive that from whoever's mounting this component. And so in the sort of story context, we have this workspace character model. And getting another error. Nil with left hand. Oh yeah, because I still didn't actually pass the character in. So this is where you pass in the character alongside these other properties. So when this, so I'll just reiterate. When this is a host component, you specify that just with a string that just names the class name of some instance, and then the properties that you pass here in this table have to match the properties of that instance. But when it's a sort of custom component like this, it's up to you to specify what properties should get passed into it. So tool app, that's the character and the color. Okay, cool. Now it's popping up right there. So let's move it around a bit.
This is so much more civilized.
So let's rotate this. Actually, I'll show you how I did this. I use this plugin that shows me the left, right, front, back. And so I'm just thinking about the left hand. Right now, the left hand is pointed down, but when it's pointed up, maybe we could actually rotate the hand manually. This might go badly. Oh no.
You could just rotate the hand and arm together. Why not?
Yeah, I could do that, but how? How would I do that?
Just select both of them and then.
Oh, okay. I'm gonna do
that's
this
fine.
horrifying. Okay. So now, okay, it's ending up there. So what I want is just for the sort of coordinate logic to make sense. I want to see the back, because then left will be to the left, like in XY coordinates. To the left will be negative in X, and to the right will be positive in X. Up will be positive in Y. So I want to rotate this way. So let's do that. Yeah. C-frame dot angles. We're rotating around the x-axis. Actually, what's neat is that when you're using this plugin, you can, and you're trying to rotate the faces, you can look at the view selector here, and I know that I want to sort of rotate this back face to be where the top is. So I want to rotate around the x-axis. So I'll do that. Math.pi divided by 2, 0, 0. Okay, that we've got the bottom on top, and I'm looking at the front. I think we want it the other way. Whoops. Minus. Stop replacing the bracket. Okay, cool. That's how I want it. And then let's change the size. Okay, so The size should be different. To 3 the new. In the X and Y direction, let's do 1. And let's make it thin in the Z direction. So the Z direction is going to be in and out, and positive will be towards us. I know that because that's what this view selector is showing me. Because I'm going to be facing the back. I'm going to be looking at the back of it. Okay, cool. Now it looks like that, but we want it to be. We're going to move it. We want to move it up. So up, and this genuinely is up in the frame of in the C frame direction. So if I take this left hand, rotate it that way, yeah, that's how we want it to look. Okay, cool. All right, what now? Let me check my notes. Okay, right now we are parenting this to the workspace. That's fine, but actually let's that makes sense in this context, but in the actual like live version of the app, we'll parent it to somewhere else. But that's a concern for the mounting phase. Notice in this story, when I mount the component, I tell it what its parent is. So we'll do that differently in the live version. Okay, let's get the live version working for now. And then we can come back to making this more interesting. So let me check where this is supposed to go. We will put this actually in via IO. Also, I noticed I picked the name IO, but that means input output. But there's no output, which this is just for VR input. So that was a bad name. Okay, so this is just the function that when you move near a board, it sort of sets up all of the VR input for that board so you can draw in it. So what we'll do here is this is where we will mount our component. So local handle, let's actually import it. Mount, let's make the app. We need to give it the character, which I'll just grab here. And let's set the color as well because we need to do that. Let's make it black. And we're actually going to parent the resulting instances to the character as well. And give it a name as well, tool app. Okay, so we've made it here, and in the logic of this code, and it should also be destroying it as well when you move away from the board. Roact unmount handle. Okay, this should work. I don't know if the VR thing is connected at the moment. Hopefully it's not. I can just, okay, cool. Um, oh yeah, it's falling down. That's that's because it's not anchored. Actually, it might be anchored. Um, I think can collide is also off.
Your sophisticated tools can't save you from this one.
um, did I parent? I've got something in the workspace. Maybe that's because I have it. I think hoarcekat was running. I think that one fell. Did it? Is this anchored? It's not anchored. Okay, so we will want to. Okay, there's a slight caveat is that uh, when the game runs, it's actually using a sort of modified version of Roact for metaboard purposes that changes the default properties of parts so that parts by default are actually anchored. But that doesn't get activated when you're in Studio. So this should actually work. So let me just check that. We should also be checking that there's actually a character here. If character, and let's try this again. Oh, it made it and anchored it there. Okay, that worked. So now we don't want it to be anchored. We want it to be welded to your left hand. So let's get that working. So this is how we can do that. I haven't shown you children yet. So this is how you get host components to have child host instances. Sorry, to have children instances. So there is a special key which you access through roact.children. And this is a table where the keys are going to be the names of those resulting instances, and you pass it in an element. So here I'm going to create a thing called weld, and it's going to be an actual weld host component. And what am I going to weld together? I'm going to weld together the character. Actually, I have it just in the variable character. And then part one. Well, this is the sort of this is the Rubik's puzzle that we can't solve yet because we want this second property of the weld to be the instance that is created by this sort of host component. But this function here, create element, that takes a host component and the properties. That's just a sort of virtual Roact side thing. It's not the instance itself. The instance only exists when the whole thing mounts. So, but we're in the middle of the function that sort of tells Roact what to mount. So it's a bit of a puzzle here what we should actually write here. And the solution is that there's this concept of a ref, which is just it's a reference to the actual instance objects. And there's certain stages in the Roact lifecycle where you can retrieve the value of this ref through get value, and that actually gives you the actual instance. But I'll show you how we're going to use it. So we need to create a ref that is going to refer to the instance that is created by this component so that we can connect it to this weld. And we have to do that in a certain stage of the life cycle. So So let's the way you do this, I don't think I can like fully motivate this, but there's an init stage in a Roact component's lifecycle that happens before render. You can see the whole life cycle here. There's a good diagram. This explains like so you mount your components. The init method gets called, then the render method that actually creates the instance, and then there's a did mount method that it calls, and when you update the properties of state, there's a whole bunch of other methods that get called in different orders. Um, but the key is a lot of things you're not allowed to actually access in the render stage. You have to do it in some of these other stages. So in the init stage, we're going to create a ref um, with this function, create ref. And that we need to do two things here. We need to tell it which instance or which host component is going to become the instance that we want this to refer to. And we then can also make use of that elsewhere. So what I'm going to do is this is how you tell it which instance it's supposed to be. You do roact.ref in the properties of the host component equals self.part.ref. And that does some internal Roact magic. And then when we want to make use of this and sort of refer to the instance created by this host component, we just use it here. You might think we might do something like get value here, but this won't work because the instance doesn't actually exist yet when you do the first render. So this wouldn't actually make sense. Just by assigning the sort of the ref itself, Roact takes care of if this instance ever changes, it'll hook up this property to that new instance, and so on. So this should work now. Did all that make sense?
Yeah, it's clearly indicates some of the shortcomings of a declarative model based on the idea of a tree, I suppose, but it's it makes sense.
Yeah. Uh, okay, so let's get this working. Oh, cool. I'm glad that made sense. Um, okay. And to call a table value. So, I called it. So I'm going to assign it. Did I assign it? Oh, yeah. I don't know what that error is about. Cool, an actual error. Expected base part got model for weld parts. Okay, I gave it. Right, I tried to weld it to the character. I need to weld it to the left hand. Hello. Is this syncing properly? It is. Okay, let's do some printing. It might not actually be mounting the component at all. Yeah, it's not doing anything. Oh, I know why. It's because of the thing I didn't undo before. So when I'm using hoarcekat at the moment, I need to have this in replicated storage. When I'm playing live, I shouldn't have it there. Okay, I'm welded to an anchored part. Um,
Good job.
Awesome. Okay, let's unanchor it. Anchored equals false. Cool. It's in my hand, and
The rotation's off now. Why is that? Oh, the world is done before the. No, that doesn't make sense.
uh, let's check my notes. To the left hand. In my notes, I did get pivot. Let's see if that shouldn't make any difference. I don't think. Um, Let me make one of these values a little more extreme. Hmm. That's weird. Let me just compare this to what I've prepared more thoroughly. Is it like falling or something for a second? I feel like that shouldn't happen.
Seems unlikely it would fall in that exact way.
Yeah, there's no yielding, so nothing should actually change in that time. Um,
Well, does the world maintain the relative orientation, or does it just? I forget how worlds work exactly.
oh, I know. We don't want to make a weld. We want to make a weld constraint. Um, I think a weld has to like actually be contacting. Yeah, there we go. There we go. There we go. That's much better. Let me change this back to 1. Okay, and let's try and get 2 buttons on there before we finish. Even if they're just decorative. Oh, I pressed a function key. Oh wait, it's back. Okay. So you'll notice that we have a part ref for this particular part, but if we want to make more of these, and that's going to involve having different part refs, but for each one. This is a good for each different part that we're using. This is a good opportunity to make use of a component which sort of takes care of all this welding for us, and we can just pass stuff into it. And so this is going to be our, I'll call it welded part dot lua. Roact welded part. Roact component stand. And it's going to have, it has its own init method. Welded part init. And we're going to do the exact same thing. But this is going to be the part ref just for this component. So let me take this code and we'll put it here. Okay, now the immediate downside to this is that like we want to be able to use welded part here. So actually let me just import it first. Okay, we want to use it here and we want to sort of pass it in props as if it is just a host component. But at the moment, because this is a custom component, the props just going into self.props. So we would have to like manually assign each property to sort of pass it into the part host component. But what we can do is take this and let's make a specific prop that is just like the purpose is to pass through the props for the part. We don't want to do any of this. So we want it to take care of all of the welding stuff. And we want to treat it as if it's a part and we can just pass in whatever properties we want. And inside here takes care of all the welding stuff. So to do that, let's take care of just this part of it is, okay, we've got part and the children here. Oh, sorry, I'm doing this inside the init method. So, okay. So we have these properties, like the children and the ref for this instance. We want to sort of mix it with the properties we've passed in here. And that's why it's good to have a library like Sift, which takes care of a lot of immutable merging of tables. And so that's what I'm going to do here. So I'm going to do dictionary.merge. And this sort of takes in any number of tables, starts with the first table and assigns to it the keys and values of the consecutive tables. So we'll start with this table we have here, and anything we want to overwrite will come in self.part props. And so in particular, we don't want to specify anchored every time. So let's just make it so that it automatically sets the part the anchored property to false. Anything else? Everything else will pass in manually. Okay. And yeah, we don't have the character, so we could pass in the character, but really we just want to we want this component to accept a sort of target thing that you want to weld to. So when I use it, I'm also going to pass in a target, which is I'll weld it also to the left hand. And so let's just check that that worked. I didn't return anything. Yep. Okay, so that's still working. So now let's make this more interesting by, so this is going to be, it's going to be our menu surface. And we're going to have a pen button, which is also going to be a welded part. I'll have different part properties. Let's make it start at the origin, but then let's uh, move it. Actually, let's shift this thing like down a little bit. And then let's move this one to the left a little bit. And let's make it much smaller and give it a different color. And so we still need to return something. We'll return the menu surface, but because we have two parts, we need them to be to all exist somewhere in the hierarchy. So I'm actually going to parent the pen button to the menu surface. I'll give it a name. Pen button equals pen button, and let's see if that works. Is it there? Tool app. It's not there. Did I forget to return something in the welded part? No, I didn't. Anchored false. It's not anchored, but it is welded.
What about the buttons?
What do you mean?
Well, those parts are not that part, right? Oh, I see. That's what. Yeah. Right.
So we got two different. So with the main welded part. Oh, okay. Yeah, this is the right problem. So I wanted to treat this as if this was the first component. And so I passed in the child key. But here what's happened is that when this merge happens, I've set the child key, but then I override it here. So how do they solve this? Yeah, I just did it like this. I did another merge. I take this and I'm going to tack on the Roact.children that got passed to me.
This is so much clearer than imperative UI.
Oh yeah, well we're at the ground floor where everything always becomes more complicated when you add abstraction. When you're doing very simple things, but then when you scale it, it becomes a lot more manageable, and you can actually get a lot more done. I think it just literally fell again. I saw it for a split second. Let me just we'll look at it in hoarcekat for a second. Oh no, it was just hiding behind it, I think. Let me just double check that's working. Oh yeah, and actually this is how I would make use of hoarcekat is like we don't have to run the game if we're just concerned about positioning things. So I would go what did I do? I moved this up. Actually, oh no, the Z is in the negative direction if I want it to
That's
move
size. You just made negative.
Whoops. I want to move it back in this Z direction. Okay. Cool. That makes sense. To make it look prettier, can do material equals hold up. Maybe plastic. Cool. So there's the beginnings of our UI. Probably hold it there, but uh, the interesting part we didn't get to is then how do you take this and make it react to pressing buttons, and how does that influence the state? And we didn't actually get to make any state yet. At the moment we just have static props that don't change, but gets interesting with state. But I should probably leave it there. So thanks for watching.
Yeah, thanks, Billy. I think that was useful and also a nice introduction to Roact. Yeah, that's particularly for me very useful.
Awesome.
Ethan,
Any questions before we go?
Yeah.
Oh yeah, I'm glad you're keen to try hoarcekat. It's yeah, as I said, you don't need to use it for Roact. I guess it's how I pictured. We were talking about like a C-frame plugin where like you can just try out different. Like here, it was really cool because I could just sort of adjust the values I'm using, change a minus to a plus, and it would update instantly. And like the way that works is that hoarcekat knows how to create the thing and destroy the thing, and so it can automatically like the hot reloading the code is sort of a more complicated thing, but just the idea of calling a function to build the thing and calling another function to tear it down is a pretty simple thing to implement. And so yeah, that's how you get the sort of live updates. So yeah, you could do it. It doesn't have to be a Roact thing. It just could be I'm creating this thing with code and I want to sort of iteratively see what it looks like and modify it with some live updates. hoarcekat's good for that.
Yeah, that's awesome.
Any other questions?
Seems maybe not. Okay, let's switch over into MetaUniDev. Thanks, everyone.